Hello, team. Here we're going to tackle 2-59, which is a similarity problem. We're starting with the picture that was in the book. We originally started with A, B, C, those 3 points, which made up a triangle. And then there was a dilation through a point of dilation. Now, the point is like the center of dilation, and if you think of taking an object, and if we're going to I'm just going to look at a single point, and I want to dilate it a certain distance away from A, I can actually think of this point as being on a circle, so that when I dilate it, I actually make the radius of that circle bigger. So in this case, if I was to make it twice as big, it would move out to there. If I had another point here with that same radius, then it would also end up on this new circle with the same double radius. If this initial point was called point B, the point that's translated, it is translated but it's also dilated, any kind of transformation, I use the notation B prime. If this were C, this becomes C prime. And so that's what's happening here. Except we started out here with B and C, and then dilated towards point A. So we're shrinking the triangle back up towards point A. So that's the similarity and dilation component of this. Now, if we've done that, if this is just a dilation, that means that we know that the pieces of this triangle are going to match up with the pieces of this triangle. And in fact, we're going to know they share an angle here. We know that this angle is congruent to this angle, and this angle is congruent to that angle. And we know that because this is just a shrunken, a dilated version of the original bigger triangle. So it's the same shape, just a different size, and that's the very definition of similarity. If that's the case, we can look at these now as two separate triangles. Look at the little one, A, B prime, C prime, and the big one, A, B, and C. Now putting in all those congruency marks for what we know is congruent. So now we've got those pieces. Now what we're going to do is we're going to look at the pieces in the original and how big they were. So this part was 4 and this is x. So A to B prime is 4 units. A to C prime is x units. Now if we look at the bigger triangle, this is where we have to be very careful. A to C is all of that distance. So it's actually x plus 9. X plus 9. And A to B is all of that distance, which is 4 plus 6, or 10. Okay, so now we have these parts written out here. If these are similar triangles, it means the sides are in the same proportion. And so I can write a proportion from big triangle to small triangle with the corresponding parts. And so I could compare AB to AB prime. And when I do that, I'm going to get AB was 10, AB prime was 4. If I do the same thing for AC and AC prime, so big to little is AC in comparison to AC prime, which is going to be AC is x plus 9, AC prime is just x. Now since these are in similar triangles, we can actually set up a proportion of 10 over 4 equals x over, or equals x plus 9 over x. And so that's the first proportion we can set up.